Exercise 3A is just a review of the log rules. This is quite a nice little table because they actually show you the index rules and the similar log rule. Now, you might be wondering why they're showing you the index rules. Well, if we think about the definition of a log, the log of a number to a given base is the power or the index. It's the power. So, of course, rules concerning logs would be similar to rules about powers. We know that when you are multiplying the same base, it's more the focus on what we're doing with the index. We add the index. If we add logs, because remember the log is the index, add logs, where did that come from? It came from multiplying. The division rule, no surprise, is subtract the logs. And raising to a power, we multiply indices. So we're raising this log number to a power. So of course, yes, we bring the power to the front and we multiply. Some interesting situations that you should be really familiar with, that log of 1 to base b, and b can be anything there. The log of the number 1 is a 0. Where does that come from? The way that we get the number that you raise any base to, and the base being b, in order for it to turn into 1, it must be the index 0. What do you raise b to get b? The answer is 1. And this next one is just an understanding that, I'll do it over here. If you've got log to base b of 1 on b, then you can write that as log to base b of b to the minus 1, which is, now that's not a log rule, that's just an index rule about 1 on b. Now we can use a log rule, bring the minus 1 to the front, and we're taking the log of b to base b. And now we're using another log rule, which is that log of b to base b is 1, and so we've got minus 1. And the next one is very similar. We would write this 1 on x, not using a log rule, just using our understanding of negative indices as x to the minus 1, bring the minus 1 to the front. Also remember the change of base, log of x to base b is, or c to some unknown base, can be written as log of x to base b over log of c to base b. Now, the nice thing there is that we can choose our b to be 10 or e. And in that way, you can use your calculator, but more importantly, the focus for this chapter is going to become calculus. So if we want to differentiate, we learn how to differentiate log to base e. So if we have a situation where we're being asked to differentiate any other base, then we'll need to use our change of base so that we're setting up a quotient of logs, but they will be to base e, because the only thing we learn to differentiate is a log to base e. These two sentences are just saying that same thing again about the calculator only has two options for bases, and that is e or 10. And if you want to use, if you want to evaluate to any other base, or when we start to differentiate, if you want to differentiate anything to a different base, then you'll have to use your change of base rule. Okay, let's have a look at this example. I really like this example because one, it's difficult and you need to be exposed to the more difficult questions, and really this is a review of logs, so it's not we need to practice the basics. No, we did that in the year 11 chapter. We now need to extend a bit beyond the basics. We need to be using various rules possibly within one question, and that's what you'll find you have to do here. It also is a good opportunity to talk about the importance of techniques in maths. So you're going to see what I would say is a technique, and it's not a rule, but it's just a way of approaching an answer, and one to be aware of. So what's this question asking you to do? It says use the change of base result to show that log of b to the base a to the x is log of b to base a on x. Now, you could use the change of base, and using the change of base is not the way I did it in class with you. I really liked the way I did it in class with you because it gave me an opportunity to talk about a technique where I said, well, let y be equal to this log to base a power x to the b, and then we manipulated that and showed that we could turn our left-hand side into our right-hand side. I'll now show you on the video, actually following instructions, using the change of base. So the left-hand side is equal to log a to the x of b, which we know we can change base and say log of b over log of a to the power x. Now, I guess at this stage we need to choose which base. I'm not going to go to base 10 or base e because I'm not differentiating, I'm not using the calculator. I am going to go to base a. Now, for two reasons. One, it's obviously appearing here in where I'm heading, so that's why we love a show question. Always keep in mind what we're heading towards. You can actually see it. So that tells me that I want log of b to base a basically here. And I know that if I've got log of a to base a, then that is 1. So continuing on, that then would be equal to, I don't need to do anything to the numerator, all over, I'll use the rule, bring the x to the front, log to base a of a, which is, we know to be 1, and so we've got x times 1, which is the right-hand side. Then in part 2, you're asked to evaluate this, hence means use that rule. So we're trying to see a connection between this question they've given us and this rule. So the thing that is not quite the same as the left-hand side, but almost, is this root 27. Would be nicer if it was written as a base to a power. Well, that's not too difficult to do. So we know that log base root 27 of 81 would be equal to the log of 27 to the half of 81. Now, according to this rule, we know that that is equal to the log to base 27 of 81 over a half. And we know that when you divide by a half, same as multiplying by 2, so we've got 2 log to base 27 of 81. There's a few different ways we can do this. I'm thinking that maybe could we do change of base again? Log, which is again different to the way we did it in class. Log 27, which is base, and I get to choose the base. And because 27 and 81 are powers of 3, I'm going to talk about this as base 3. remember, that's the nice thing about change of base rule. You actually get to choose the base that you want in your fraction. So thinking about 3 to the power 3 is 27, and 3 to the power 4 is 81. I know that this is equal to 2 times the log of 81 to the base 3. What power do I raise 3 to get 81? Obviously I raise it to the power 4. Over what power do I raise 3 to get 27? It's over 3, and so we get 8 on 3 is the value of this, and at no stage have I used my calculator.